I feel that I cannot really share with you the way to learn WebGL, or the way to in the way that I'm writing, or learn the way I'm building a GAN model in 1 hour and a half. But I'm sharing with you some very great content about data visualization, not just with this presentation, but with some file that you receive later after this presentation. So essentially, I think I work in an area of beautiful data science. So that is inside to this field there is almost everything. But my favorite part, of course, is the artistic part. And I think you need to know history of art to really improve your aesthetic sense. So understand very well what are the different perceptions of beauty around the world. And this can really help you a lot in building great data visualization in terms of aesthetic impact. And then the coding part, I think some great example is in NIPS creative collection of projects. So in NIPS every year there is a collection of almost 20, 30 projects that go in this kind of gallery. There is a physical gallery inside to the NIPS conference. If you don't know what is NIPS conference, is the main conference in area of a neural net. And I think it's a very nice community, and I was there a few times. So you can find some of my projects in this link. And then we have the statistical, learn about statistics. Of course, it's not my field, but without this skill, you cannot really explore, identify story. And then the beautiful variation of knowledge all the people have in this room. So you are the only main actor for understand deeply your data. So, and people like me can just work with you to make a little bit better your story, but the great story just comes from you. So essentially data visualization is going two sides, scientific visualization and information visualization. So what is scientific visualization? What do you think it is? Well, essentially when you really present what's going on the planet in terms of wind is moving, the variation of temperature, the combustion inside to an engine, everything, all these direct representation of reality go in this category. So in this case, we have a beautiful visualization I built many years ago in MIT, and this is the famous canyon effect. I think this visualization can change your life in a bad or a good way. Let's see, make you a little bit paranoid. Essentially, in any city, these are two buildings, and this is the main street. So let's watch again. The wind goes in this direction. And when the wind goes in this direction, it creates this movement on the street and push all the pollution that comes from the car, they are in the center, to the left. So now you know that every time you walk, there is one side that is full of pollution, and the other side where you can breathe very clean air from the sky. So you need to know which the direction of the wind. So I'm happy to introduce you in this paranoid way to walk that I do every time. Now you know when I meet me why sometimes I change side of the street, always looking for beautiful and clean hair. So don't forget this tip. So then I want to introduce the idea of information graphics, the way to plot data that are abstract, where there is not really maybe a geographical representation or physical representation that you can take advantage to plot the data, but you need to identify the strategy, you need to identify the layout. So this is one of a project I built a few years ago, and essentially the story is very simple, and I think it's very close to interest. So there are two different nodes, blue and red, that represent Democratic and Republican, and then there is a connection between these two people if they vote together, something, on the Congress. And the thickness of this edge is related to the number of votes that they did together. So let's see what's happened. So this is a little video that shows you the story. Of course, there is some ugly sound on the background because when you work with a journal, you can never have the power to choose the sound. I don't know why, but there's no the condition. So you can see the year after year, Congress after Congress, you see a different level of collaboration. So more these two groups are close, better is the collaboration between the two parties. And slowly, there is this separation. You can see the separation. So this is a very well-known phenomenon about polarization of a party in democracy. And USA is a very good example of what's going on all around the world. So this phenomenon of polarization, unfortunately, is really unfortunately because this level of segregation of the two parties and no collaboration doesn't help democracy at all. So I think the beauty of this visualization is to see one by one what's going on in every single network, but see all together the temporal network is very meaningful because you can see that is a phenomenon that just happened today, and you can see quickly when it starts and when the situation was completely different. And of course, there is an interactive version of this tool online that I will release very soon, where you can click every single dot and understand who is this guy, and zoom in, zoom out in the big picture, in the small picture, so you can interact with this information. So I want to highlight with this example that beautiful and meaningful visualization give you the small and the big picture simultaneously. So small and big mean that you have a big overview of what's going on in your data set, but if you want, you can zoom in and understand why this happened and who are the actors that are the protagonists of this change. So just to explore if you know some of my work. Do you know this project? How many of you know this project? I feel lucky today. I feel very lucky because it's a record for me. 7 people in the same room. Yeah. Well, let's see some little theory, very, very light. So I think why we do visualization essentially is to record the information. You can record some event just by using visual artifacts. Then to analyze the data and think about this data. Quindi, so it's a form of expansion of your memory because you don't need to remember many information. You can frequently we just sketch, not to clarify our mind, and of course find the patterns and discover the error in the data and make some hypothesis about your data. But I think the area that is not really well known in a scientific community is the power of this last component. So when there's a time to share your content and the dissemination problem. So try to be persuasive, try to convince other people that you're right, that your idea is good, but more than that, because it's science, so you don't want to use rhetoric to push people to follow you and your idea, is to help other scientists to link your project with some meme, with some picture. So, and this will help other scientists to maybe talk about your project in the future. So you know there is an overproduction of paper in any field. So more and more the communication area is in the scientific field become important, just to help other people to connect the dot. So more or less, I think we can split the problem in these two parts. Every time that you make a visualization, yeah, I know it's very unpolite, it's no political correct. I know. Okay, I need to leave. You need to stop to record again. No. So, but this is a very famous example. So you can find many books about data visualization, and is the value of the diamond over the time. And there is this, I don't think, a very polite idea to link the value of the diamond to the leg of a woman, because when you buy a diamond, if the cost is, if the diamond is very expensive, for this author, not for me, you have more chance to be, I don't know. Well, anyway, this is the reason why he used this. So it's very provocative. So the idea is to use some provocative picture to help your brain to remember the trend. So I don't think you will never forget the value of diamond after this visualization. You need just to remember a leg of man or woman and think that now the cost is so low that you cannot impress too much other people, apparently. But if we use this approach, that is very minimal, where every single pixel is very well calibrated, we have the opposite effect. Everything is very clean, but you lose in memorability. So your visualization become anonymous, and together with other visualization, will be impossible for other people to remember all the data that are in a report, remember all the content that are in your paper. So if it's just alone, it's okay. But if you use together with other data visualization, you need to try to put some effort to customize and make a little bit more memorable the visualization. So more or less, again, we can divide the problem. It's a very strong level of simplification, I think, help you to think about visualization in a more deep way. You make a visualization just to read the data. So you want a very efficient analysis and interpretation of the data, and you don't want any decoration, any artifact that can distract you, because you know what you want to see, or you know what type of trend or pattern maybe is in the data, and you need a very clean visualization to find. But from the other side, when we go not to the area of exploration of the data and looking for pattern, but when we know the story, when we find something, it is a time to share our knowledge, you need to be in this side and try to introduce emotion in your data. So feeling the data mean link the information with something, with some rhetoric story. This is very, I think, easy to understand. So there's a number of people that died in Iraq, and the bar chart goes in the opposite direction and look like a blood. So there are many examples of visualization that try to match that content with some story. For example, the raining around over the year, and you use something that looks like rain to express and with feeling this data. So I think these are key questions that you can read later on the PDF that we'll share with you, but every time you start a project, I think is a good sequence of questions to ask you, for you, and maybe you're building some project now, so you can introduce your question, your brainstorming. So this is more like an area in a moment where you need to find the data, and you know what is your goal, in what direction you want to go. And I'm sharing with you a huge collection of links that I use frequently to collect data. They are free available, and especially a lot of API that companies share to read the data in real time. And so the data set exploration of the possibility of different data sets have at least a vision of what is available today in terms of data that you can use is crucial just to be in the field. You need to know what is possible to do. And possibility mean understanding the variation of data sets that are available. So these are a key problem. Sometimes the data sets are not really public available, and there are multiple, I think, efforts that you need to do to find it. But I think data sets that are not public available are less interesting for people that work in data visualization, because you don't have a competition. So you cannot show the other people that you are the best. And it's important things. Of course, these are kind of traditional way to think about the wrangling. So the idea of parsing and clean and store, and essentially is a data-oriented approach to the idea of to the problem of data visualization. Some more question about the perspective you need to have, and the way to match the dimension that you have in your paper with the characteristic of your data. And I think still after so many years, we can look about Bertin overview of the way to link shape, color, texture, and with different type of problem. So if you don't know Bertin, I think could be a very good investment to buy his book. The now is, I think, is 100 years of 67 years from the publication. 50
years. 52 years.
Yeah, 52 years. So a little overview. So this is a link that I suggest you to use. We can watch a little bit together, and is about the story of data visualization. So it's interactive and give you a nice overview of the history of data visualization. Do you know this website? I'm so happy to give you this tool. So history of data visualization can look like a boring and no useful things to do, but in reality is a very cultural problem to understand when some type of visualization start to emerge. So I think it's very interesting just to know for personal culture, but give you a vision about what can come next, what is a trend today, and feel confident when you plot the data in some way that many other people did that before you, so you don't feel original. And I know it's bad, but at least you know when you start to build something very new. So you need to know the story of data visualization to be an innovator in this field. So let's avoid to watch in detail, but you can see this map is very well done. It's one of my favorite maps to look at the story of data visualization. And there are some people that merge with a beautiful collection of Dataviz, and these people, if you don't know these people, probably you are not from the field, so don't worry. But I think it could be very nice to explore a little bit in Wikipedia who are this person and what they did it and why. So let's back to the presentation. So essentially, there are some visualization that I really like it, and I think are really always useful to use. And of course, network, tree diagram, dendrogram, arc diagram. I think a visualization that you will use very soon, or maybe you are using in some of your projects. So we will see some example just to understand a little bit in what way they work. And what I like that you don't need when is a time to conceptualize the collection of Dataviz that you want to use to share in your story. Maybe you can brainstorm me by just sketching this visualization before to put R or some JavaScript code on top of that. So I really suggest you, every time that you have a nice story, to try to think in what way this data visualization can talk together to share with other people part of the meaningful pattern that you are able to discover in the data. Essentially, you can see each visualization like an actor, and these actors talk together. So, for example, the fun diagram is very good to propose some prediction. So essentially, where the storm will go will be the trend of the GDP after this point. And slope diagram will help you when there is some maybe some cross-fertilization between different dimensions from your data set. So the relation between these objects, when you have a problem to identify relation between different objects in your data, so you have different nominal category, the chart diagram that you can find easily, like this example in D3 collection. If you don't know D3, but for you, because it's very easy to use and don't need a lot of skill to just plot a very sophisticated data visualization. Essentially, you don't need to plot and understand what way the math work to make this data. You need just to link that visualization you find in the code with your data in the right way. So it's very easy to use. The dendrogram is very meaningful when you want to find the root of, for example, a different type of species and the connection with this species. And of course, the network is absolutely one of my favorite visualization. So let's avoid to talk about Dataviz too much. It's not the goal of this talk, but I want to highlight this website to you. So dataviz.com. So and you can easily, let's see together. Just 1 second. You can identify the type of data that you have and the type of define by looking at your data set in what way your data set match with this different category, and then there is a suggestion from the system, and maybe you can see some example from the system. So the collection of the visualization that this web page offers is very huge. There are really 100 visualization, but more than that, display in a very good and meaningful way the way to use it. So just use this page is one of my favorites to understand more in what way to use data visualization. I'm sharing with you a PDF that I think will be very, very useful with a big collection of blog to follow to enter in the mood of data visualization and to become a nerdy Dataviz guy. And then a collection of artists, studio, experts that maybe you can follow, or you can just click this link to see some beautiful project and take some inspiration. So the list is very long. I just screenshot the beginning of this list, but it's very long. There are 8 pages. So you have an incredible amount of resource to see, to explore, and maybe you can call one of these company studio to do a collaboration. So my favorite part in area of data visualization is when it's time to transform the story, so in the area of dissemination, in a movie. So I really love to do that. So usually when a friend asks me to do it, if I'm free, I'm do it. Doesn't happen very frequently that I have a free time, but I really love to do it. So I'm showing you 2 examples. The first one is a scientific career predictable? I think it's a nice question for you. I think you're curious to know if it's predictable. Do you know this paper? Nobody of you know. Well, 5, 6. Do you know the video? So you know the paper, but you don't know the video. Oh my God. Okay. It's good, obviously. You're a serious person. So let's see. I need audio here, so I don't know. Is an option? Is it possible? It is not an option. I don't think so. So, so if I put the laptop this way, it would be cacophonic.
In 1928, a fungus contaminated a petri dish and killed some of the bacteria living in it. Famously, Alexander Fleming investigated the phenomenon and discovered penicillin, an accidental and lucky discovery. Many scientific careers are made up of serendipitous successes and failures. But it isn't all luck. A scientist's productivity and ability matter too. So is it possible to predict who will make an exceptional discovery and when? Is a scientific career predictable? To answer these questions, an international team studied the research publications of many scientists from different disciplines. Take, for example, Richard Feynman, who was awarded the Nobel Prize in Physics for his work on quantum electrodynamics. In his career, Feynman published 32 works in physical review journals. Scientists measure the impact of a discovery by looking at citations, that is, how many other scientists around the world mention the discovery in their work. Let's look at the number of citations that Feynman's works received in the first 10 years after publication. His highest impact paper, Theory of the Fermi Interaction, furthered our understanding of the particle physics behind radioactive decay and received 330 citations. You can see that he published 2 more highly cited papers in his career. In this way, the team reconstructed the careers of more than 20,000 scientists from disciplines including neuroscience, ecology, physics, chemistry and economics. All these careers look different, with valleys and peaks of impact. To identify outstanding discoveries, the team focused on the highest impact publication by each scientist, shown here by the red dots. The data showed that scientists tend to make major discoveries when they are young. This finding matches previous research on creativity. For example, the first line here represents a career of 23 years. This scientist published his breakout paper in year 5. The second line represents a 14-year career, with the highest impact work published in the first year. But when the team examined the reason behind early creative success, they stumbled across something that surprised them. Scientists are simply more productive when they are young, giving them a higher chance of producing that big hit in their early years. If we ignore the timing and only look at the position of the highest impact paper in the sequence of a scientist's publications, we see that the highest impact paper can be, with the same probability, anywhere in the sequence of papers published. It could be the first publication, it could appear mid-career, or it could be a scientist's last work. In other words, impact is randomly distributed within a scientist's body of work, regardless of discipline, a result the team named the random impact rule. But scientific careers are not entirely random. A scientist's ability matters too. So the team developed a model to untangle the effects of luck, productivity, and ability. They came up with this equation. C is the impact of an individual publication. P is luck, while Q captures a scientist's ability to take an idea and convert it into a high-impact discovery. Each scientist has a unique Q value, which can be high, like the scientist on the left, or low, like the one on the right. Luck, or P, fluctuates throughout a scientist's career. Unsurprisingly, great discoveries seem to be the result of both luck and ability, or Q. As Pasteur said, fortune favours the prepared mind. We might expect Q to increase over the course of a career as a scientist becomes more experienced. But it doesn't. An individual's Q value seems to stay constant. This could make Q a more meaningful measure than currently used metrics such as total number of citations or the H-index, which do increase over time. Nevertheless, there are lots of questions. What exactly is Q? Could we train scientists to have high Q? And should we use it to make decisions about funding or an individual scientist's career? There's plenty to discuss. But take heart, with a bit of luck, your next project could be your most successful one.
Cross your finger. And so usually at this point, everybody asks me, how can I measure my Q factor? I'm not the right person to ask. Maybe, Nicola, you can say something more about that. But it's very hard to say. And I think I want to be focused really in a way to share all the results from this Nature paper. And usually it's a combination of two factors. The video give you an overview and try to make you exciting about the discover, the data, and then people won't really touch from itself the data. So usually you need to link the video with an interactive visualization. And in this interactive visualization, everybody can really explore the data and don't discover nothing new, obviously, but feel more exciting, maybe try to identify some curious question, like let's see what is the medium level of citation in this field or this other field. So push people to explore. So what we discover is that interactive visualization are not really well accepted from the audience. So if you have a very specific audience, like your colleague, so okay, they have really a strong motivation to play with interactive tool to explore the data, but normal people just stay a few seconds, they just click in a random way everywhere and they leave. And this is a reason why, for example, New York Times decided to really reduce a lot the budget for the Dataviz group in a very incredible way, because all this effort to make more sophisticated Dataviz was not really, don't have any return. So the visualization, they become a video, opposite, is very well done, can give you a lot of satisfaction. So 1 million of people can follow the visualization and remember the story. So another video, just the last one, to talk about this section of transform a paper in a story. I want to highlight with this video, and you saw something before, that there are multiple types of visualization that are together. And I think by looking this type of video, you can learn the way to build a storytelling by using visualization like an actor, like what I told you before, and understand what way move one first, the others after, to make the audience exciting. Otherwise, if you stay for 3 minutes with the same Dataviz, nothing really good. People will leave the visualization after a few minutes. So, Network Hurt, do you know this project? No? Okay. And it's talk about our planet and all the problems that we have with the complexity of interaction between different species. So it's just 3 minutes. This is the last video that we watched together today. So let's see.
To live on Earth is to live as part of a network. A giant web where almost every creature depends on others for survival. These networks are so complex that it's difficult to predict how resilient they might be to changing conditions. Let's take an ecosystem in Australia, where certain plants have a symbiotic relationship with various ants. The ants act as bodyguards protecting the plants, who in return provide food and shelter for the ants. But it's not like every kind of plant has its own species of ant. That would be much too easy. In fact, each ant can visit a variety of plants, and each plant benefits from the protection of a number of different kinds of ant. You can see how quickly a network becomes very complicated. Let's take all the plants in the ecosystem and draw lines between any two species that share the same ants. This ecosystem can be represented by a network. The plants are the nodes and the connecting lines are the ants. Two plants are linked if they share at least one ant species. If they share more than one, the link is even stronger. By helping the ants, these plants are also indirectly helping each other. The success of one plant might lead to more ants, which could benefit another plant. Having lots of connections also means the network can adapt to change. For example, along the bottom is a list of all the ant species in the system. If one of these ants disappears, the network can compensate. It's resilient. Up to a point. As we remove ant species at random one by one, the connections in the network grow weaker and start to disappear. As we go along, as well as losing whole plant species, the abundance of remaining species gradually decreases as well. There comes a key point for every network where the population of the remaining species suddenly crashes. The network can no longer compensate for further changes. Where this point comes represents the network's resilience. This resilience is usually thought to be completely unpredictable, as it varies so much between different networks. But researchers have developed a new tool to try and simplify things. They started with complex multidimensional networks, all with different properties. The clever part is then using various mathematical techniques to transform all these networks into a standard model, in which the crash is always in the same place. This means that the resilience of the original networks is now predictable. This can be useful in predicting how ecosystems might react to environmental changes. Climate change, for example, can affect all species in a network and their relationships, weakening the strength of all the connections. This can make the resilience of a network so low that it might only take the removal of a handful of species to bring about complete collapse. This is particularly worrying for already fragile ecosystems, in which a tiny change could cause the extinction of a whole host of plants and animals. That's why it's important to have tools to predict and prevent these catastrophic network failures, like the disappearance of honeybees or unexpected collapses in commercial fisheries. And these models don't just apply to ecological systems. The same tools can be used to examine networks of people, from social networks to the spread of epidemics. banking networks in a financial crisis, and even networks of air traffic, in which a single problem could cause huge delays. Models of all these things are often available already, based on specific real-world data, but these new mathematical tools can be applied generally to a whole range of different systems. They should allow us to predict how any network will respond to change, and could even suggest specific strategies for preventing catastrophic damage. Whether it's plants, planes, or people, we may be a little closer to understanding the giant, complex networks of our planet.
So, any question about the way to build a video for nature? I can give you some tip for your next paper. So, first, you need to start the collaboration almost 2 months before with the communication team in nature. Then, some people will reach you and start to work with you in a storyboard. So the storyboard is a starting point to share the meaning of the story. As soon as they understand what you want to show, you are in the right path. Then start a very, very, very big and strange problem. There are two actors, the scientists and the people from nature communication. It's not a journal, the people that work in communication in nature. And then you, in the middle. So scientists don't want to change any word. And communication teams say, nobody will understand this word. So, and I'm in the middle. And I need to find and negotiate in what way, recover in some way the meaning of a very specific word in a way that many other people can understand, but it's not really the same meaning, but almost close. So at the end, scientists will hate you until you don't have a huge amount of traffic because you kill the meaning of the paper, and the communication team will tell you, oh, this is an horrible work, nobody will understand, because you try to make it, until you don't have a huge amount of traffic. So if you don't have a huge amount of traffic, you lose many friends. So I don't know if you have any question about the way to build video with data, because in this case I'm jumping to a new section, building interactive tool to explore data. Do you have a question?
No, I would like to see the interactive.
Oh, the interactive tool. So I choose for you two interactive tools I think are very close to what you want to do. So first, News Explorer. So I think the best way to explore and see an interactive tool is to play with. So News Explorer is a free, available online. So now, oh, I did something. No signal. Well, I don't know. I don't think I did nothing wrong. Yeah. Rimettiamo. Oh, okay. So in this tool, you can write everything you want in this area and Berlin and investigate. So what the tool is doing is looking for the keyword Berlin and understand if there are some news related to this keyword, and plot for you a network about all the news that we find related with this keyword. Of course, every single news have a different value for us. So I don't want to enter in the detail in what way we calibrate the impact of the news around the world, but essentially we are monitoring in real time almost 100,000 resources from blog and news, and we have the copyright for everything. And And so on the left, you have a list of the paper related to Berlin. And if you click here, you have a preview of the article. You locate the article. This article is without connection, so let's watch another one. So this article here is connect with the other entity, André Lord, Berlin Green. So essentially, the network is based to the paper. I'll show you. Let's deactivate this entity. So the paper are the key of the network visualization. Then you can add the entity that are inside to the news, to the article. So you see all these entities are inside to this article, and then see organization and people. So the size of this entity, like this size is huge. Angela Merkel. So she's in this moment in five articles, and because it's a free available tool online, we just give you the 100 best article that we find about these topics. Then there is a geolocation, so you can, and there is a timeline, so we can show you this news was on Thursday night, and there is a geolocation, like USA is in some way inside to this entity. So if we click one of this paper and then we click full paper, we go directly to the article. This is not a very fast website. Let's try another one. So you can just stay in the preview or use this tool to enter in the article that look interesting for you. So usually you have a type of result that are very different compared to other system, and but independently from the quality of the result, I think it's nice to see the interaction between different components. So we have the geographical component that talk with the network. We have the list of the paper, so the node and the name of the node on the left, and you can easily read all this list, make bigger. So you maybe if you like just the list strategy like a Google search, you can just use the tool in this way. And then we have the network. I think is very powerful because give you proximity, like element used to understand correlation between article and entity. So I think one of the meaningful ways to use a network to explore this flow of information is by looking at the dimension of the node. So immediately the dimension of the node gives you a perception of who is the important guy or the important company about these topics. Then, just to simplify the life, we use this navigation system based on topics. So essentially you have a topic extraction like fashion, and when you click fashion, there are 3 articles where the fashion topics emerge. So you go directly there. Deactivate fashion. Let's see Berlin Wall. There are many articles with Berlin Wall, and you can see this is a very special type of a word cloud. When I click an entity, a topics, we have now dark gray and light gray topics. This means that this entity are related with this one. So I can find inside of this article this other entity. So it can be a smart way to explore your data set. So if I click Cold War, now I go directly to the only 2 papers that contain both topics, and so on. So you can quickly navigate in this way. And you can navigate by people, like Angela Merkel, Ursula. Okay, start this connection. Let's discover why. I don't know. Okay. Yeah. Okay. And same for example, for company. Our view is very related now with Burnout Legacy. I don't know this, but organization. Of course, the quality of the extraction of organization, companies, people, topics can be better and better. It's related to the quality of NLP that you use. But I think it is a very good way to navigate inside to the space of news information. Now, there are many other things that I want to show. I can show you about this system because it's very sophisticated. For example, you can compare entity, I don't know, Apple and Berlin, and investigate, and the system will try to identify news about Apple, news about Berlin, and then cross this information to find the subset of information that are in both networks. So essentially, you have a Berlin on the left, Apple on the right, and there is this list of entity and article. They contain not just both, but maybe they contain directly Apple and then an entity that is related to Berlin. So essentially, we use 2 degrees of separation to explore the space of news. I think it's a very powerful way and a kind of unique way to use this interactive tool. Then finally, and then I show you another interactive system. Of course, I'm waiting for your question. There is I think something very beautiful that is this Pantarei project. So the Pantarei project is essentially a big river and flow of title. So it's like a matrix, but in horizontal and with a meaningful text. So why this is interesting? Because introduce serendipity in a way to have a brainstorming, conversation, exploration. So imagine you have a multiple laptop that you connect to different screen, and you write about topic that you care about your research, and this system upgrades itself every 5 minutes. So always is looking for new news about that topic. It doesn't change very quickly, obviously, but always is upgrade itself, and it's run forever, and don't kill your machine. It's very well done. So we use this system in our control IBM news control room, the control room that killed my the previous one. But this tool is very meaningful for this type of serendipity approach. Essentially, you have different company, for example, you want to follow, and then you see all this news, and the size of the news is related to the impact that this journal are on the world of media. So very big title is meaningful information, and the brightness of the title is related to the emotional style of the article, if it's positive or negative. If people talk bad about something, or if people talk good in a good way about something. So if the comments are good, the color is bright, otherwise it's dark. So you have all this meaningful information, and I think you can try to use and see if work in your way to have brainstorming with yourself, or identify with other people, or identify with serendipity some good information that maybe you need. Now, let's go in another direction, in exploration of a static data set. So this is exploration of a news data set, but let's see what happens with if we have in mind a collection of paper. I think it's more meaningful for you, because you have your collection of paper, and you want to use this technology to explore of this paper. Now, because it's very my interest, I put this, I linked this tool on the area of artificial intelligence. So now the system is training to explore artificial intelligence. I don't know why Indonesian traditional is here. I think I made some experiment yesterday about. Anyway, we can write here everything we want. I don't know. Berlin, I don't know, gun, just because I work a lot with gun. And let's see what happened. So it's loading, and then is exploring in this moment the full collection of article in area of artificial intelligence in archive. You know, archive from so is probably a place where people put the paper before to go public in a journal. Very, very frequently this happens. So it's a very good resource. So we have the top 10 papers the top 10 authors, the top 10 organization, and of course, there are multiple methods to organize this ranking. Let's not talk about that, but let's see more deeply the visualization part of the project and not the algorithmical part. So on the bottom, you have we find for 30 papers for size, large, all time. So essentially, these are the variable that you can introduce in the tool that I will show you in a few seconds. So we find 30 paper in this time limitation that was in the system. For 503 citation and 1,000 authors, 29 affiliation in the range of 3,000 days. Let's see what's really mean. So before to go deeply on the tool, you can see there is a top keyword. They are usually related with this GAN. For example, perturbative layer. Well, this is not really good. But and then you get SETI, anomaly detection versus 9. So this can help you to maybe identify other topics that are related to your topics. Let's see the network. So there are three visualizations: the list, the flow, and the network. The network is very powerful because it can plot millions of nodes. So it's a very sophisticated engine in WebGL. We spend a lot of time to optimize for the web. And so it's very responsive. You can click to this guy that is in the center, is very huge. You know why? Is a guy that invented the gun. So immediately, the network gives you information about the space of knowledge that are around the concept of GAN inside to this data set. So an important guy is in the middle of the network, high centrality, and is a big node because many people talk about him. So when you click a person, you have all the list of paper, and if you click a paper, you can see that paper, and all the author was in this paper, and then you can select the article, and if the article was not available in the system, we go to Google. Otherwise, if the article is available in our repository, let's see another example. So in this case, we have the direct link to open the tool, to open the paper, because it's inside our repository. And you see there is a preview, the many other publications. You can click now to this guy and do the same. It's like a navigation that can be very friendly. And here you have all these list of citation, authors, affiliation. So this is a very high cited paper. So the list is full of the number of citation of this paper. So let's see something more interesting, because this is a very traditional visualization, no? But what if we are just looking the correlation between author? So the link between author. So usually it's not really easy to identify, to have this network. You need to build for yourself. There is no tool online except this. Anyway, it's free available, so you have the link now. You can use how much you want. And now you have the relation between the author. So you can see cluster of people. So if you need to find your next collaborator, try to look in this group if you are working area of GAN. Because they are very in the center of the network, they are very influenced, they work a lot together, so it's a good team. Don't work with this guy, because maybe he makes just one single publication about this field, around this content, and it's very disconnected. Nobody talk about him, nobody work with him. Yeah, I think using the author-author network help you to understand deeply what's mean being academia. Mean entering some family. And let's see another thing, the citation network. Who talk about who? And more meaningful, the co-occurrency network. So essentially we clean a little bit of this network. And you can see this paper is really important because it's always cited by other other paper, so the co-occurrence is very strong. And I think you can use this plot to have a quickly perception of what is the next paper you need to read. If it is in this list, you need to read. So the paper that emerge in this co-occurrency network are very important for the field, especially the one in the middle. Then the affiliation network, so interesting, essentially will link people with the common affiliation. So for example, here there is a Carnegie Mellon. So if you need to choose your next university, write your field, the interest that you, I don't know in what area you are working there, then go to the affiliation network and see who is a big red node. And try to apply first there, because these people are very good in that field. So of course, there is a big bias because we are using archive. So there is no integration with Nature, with Science, and with many other important publications. But you know, in archive, in reality, there is everything. There are many papers that are in Nature too are in archive. So I think can be at least representative. So of course, you can introduce in this type of interface your favorite collection of data, but in the free version you cannot. So again, we have the same beautiful matrix effect, but this is related to scientific publication. So in my lab, always there is this list of this beautiful movement in a coffee area. So during the coffee, you can see, oh my God, this paper just come out. I need to go to read. So the coffee break are very short, but you can discover quickly because, like before, we upgrade in real time, almost in real time. Well, you know, the upgrade in archive is every 2 days, more or less. So we do the same. When there is upgrade in archive, we do the upgrade in our website. But it's a good way to discover new paper. So I suggest you to use, especially in area of vision. There is a lot there. So now let's move to back to the presentation. And now, if there are no questions about, there are questions. There are questions about no question. So you can see that if you work and people pay you to build the visualization, the level has to be very sophisticated because other people have to use to explore the data and really to find some meaningful content inside. Of course, I never work alone. I have a team of other seven people that work with me, but more or less the quality of tools to explore information are this. And you can introduce more feature. Usually we introduce a lot feature for the professional version that we sell. But the free version are still very powerful. Now, after this example of interactive visualization, I hope you like it, let's see something completely different that I think is a little bit entertaining, is a project for Affluence. So for Affluence is I think is a very interesting project because the data set is very interesting and is public. So at that time when I built the project was other 2000 team that was working with the same data set. It was kind of a silent challenge from Google because this data set comes from Google. You know the game Quick Draw? You know? The game Quick Draw is essentially you have 30 seconds to sketch some entity, cat, dog, apple, train, things like that. There are more or less 500 class. They sometimes more, sometimes less. So the idea is to plot, for example, a pizza. Now, I think if you look at this composition, look very beautiful, I think, because altogether this little sketch of pizza, what do you think? It's kind of interesting. But if you zoom, the quality is incredibly ugly. So this is really the level. And I choose always an example of a pizza because it is the only one without any link to very unpolite draw. So in all other category, people always draw, you know what I mean. This is on the record, I cannot say. But with pizza, it doesn't happen. So I think it's the magic power of pizza. So when people think about pizza, there is nothing else.
No sex.
No sex, no sex. So it's an interesting discovery, but nobody wants to write a paper with me about that. So the power of pizza, like that, something. In case you're interested, I can share with you the data. So what happened if we overlap of this draw? Essentially, we have a picture like that. So these are a very simple overlapping, but it's not so simple because all these draws are really with different scale. So there is an algorithm that rescale and rotate to optimize the overlapping. The overlapping in this case show you the power outlet. This means that because we can really reconstruct the power outlet for different countries, this means the data set is representative. Because, you know, I have this data set that tell me where people come from. So I can plot a power outlet just for German people. And if I have this result, I mean, they're German because you have only 30 seconds to draw. So you don't go to watch the power outlet close to you. You draw the power outlet that is very familiar for you. So this was a little test that we did to really understand if this data set was really a representation of people around the world or just American people in holiday around the world. So is the first one. Then we divide the object in these two categories, converging and diverging. So converging means that when you overlap all the bottle from all the data sets from all the people around the world, you have some meaningful representation of the bottle. But with mosquito, with bee, you have this black hole, so nothing, a spaghetti effect. So when you have this distinction, you can start to identify very, I think, beautiful representation of mustache. So if you plot all the mustache of people that sketch mustache from all around the world, you have this sketch. You have this representation. So if you want to, in some way, is the archetype that every human have in mind to represent something. So everybody in the world, I think, cut more or less in this way. Is an archetype. And more than that, so more than discovery that for some class, everybody have the same archetype, so they draw in the more or less in the same way, we discovered something more interesting, that the sequence of movement to draw a panda, for example, are the same. So if you overlap the sketch of panda, and you go step by step, because all these data are full of everything goes, of course, if you know this data set, you don't have a picture, you have a vector. The vector that tells you the position in every single time step. So you know the velocity of the sketch, and you know exactly the direction of the sketch. So we can use this information to plot in this way. We discovered that everybody first have, it's very common from all the human brain to first identify the boundaries of the object that you want to represent, and then go to in detail. I don't know why there is a preference from these eyes and not the other one, and go to the other one, and then step by step, the data become less meaningful. And this happened to the panda, but to the eye, there is the same phenomena. Nobody starts to write the eye from the iridate. If you have a friend that do that, it's no human. It's a scientific proof. And so now you know the way to identify strange friends. And you, during your first day, please ask, can you draw a eye, please? Quickly, and let's see. So, sun, and then a face. So, of course, I was very curious why this happened, and for some psychology, this is a sign that there is no any brain disease. Your brain is healthy, but there are people with some type of brain disease that usually are focused in the detail, and then they contextualize the detail with a more bigger picture. So I discovered after presenting this project in multiple conferences that there are really scientists that are using Sketch to evaluate the performance of your brain. And with a friend of mine that is professor in network medicine in Harvard, we was thinking to do this experiment, but then still is going on. We still need to decide. So I want to propose you a little video that I think is very poetic, where you can see step by step how millions of people draw together. So enjoy. Every single draw is very fast, 3 seconds. So you need to be focused and see the movement. So nobody did it before. I was the first plotting million people draw simultaneously. First because it was not available the data set, and then because the other 2000 team, they was not thinking about that. So I was the only one thinking to this visual representation. And this gives me a big advantage compared to the other team, because at the end, Google decided to identify just one person to give to that person the full collection of 2 billion draw. And who is this guy? Who knows? Okay, obviously. And let's see the video. Lawyers. Lawyers always are the winner. A teddy bear. Nobody. So in case you were thinking, what is that? Now you have a solution. It's like a puzzle. This was a project before to receive the full data set, and now there is a version with the full data set that is in a permanent collection of Ars Electronica Museum. So in case you go to Linz, nobody go to use, but in case, no, for a soccer tour, so you can see this project with the full collection of data. So essentially, we draw objects in the same way and with the same sequence of movement. So I don't know what you are thinking when you're reading that, but I was so impressed. So it's really, I think, a message that unifies all the population from around the world, and any type of racism disappear when you see things like that, are really evident we are made in the same way. Otherwise this was not possible, but not really the same way. Yeah, there's some cultural difference. Probably your question was in this direction.
I wanted to ask if you have some specific culture.
Yes, exactly. Yeah, there are. So for example, if you draw a chair, in Japan they prefer the 3D perspective. Don't ask me why, I don't have any clue. But this is really a result that comes from a huge amount of data. So, and the only data set that talk about sketch in the world is this. So at the moment, we can just believe that are representative. And there is no way to be sure that it's not the same person that draw 1 million times the same object. Maybe an engine, there's no way. So we need just to trust that the game was very well spread around the world. We have just the IP. So we just know where it comes from, but we don't know generality, we don't know the age, we don't know the sex. So it's not really something that people can accept easily, especially in cognitive science. But computational cognitive science, they really love this type of approach. It's very quantitative. So So there is some cultural link between Taiwan, Thailandia, Korea, and Japan. Here is a ice cream for Italian are really important. So now I know that I'm connected in some way with Hungarian people and Sweden people, because they are the only three nations that draw ice cream with three balls. So we really love ice cream. So the rest of the world, they just think ice cream with one ball. That is so another criteria to select your friend. So, and this is a boomerang in Australia, and this is a boomerang all around the world. So try to guess why Australian people always draw a boomerang and go up with the arrow. Why always is this position? Try to guess. When you lunge is is all the angle. When you lunge is yeah, but when you can be in that way too, or in that way. When you lunge, in a sense, there is no a criteria what to image boomerang in this way. So, can you guess the reason? Huh?
Like drawings of the movies that have got
No.
because they have the map like up down, so the boomerang is
Almost there. Almost there. Try. I think if you will see the solution, you will say, come on, that's so easy. Try.
because they do not use it and only see on pictures.
Huh?
Because they do not use it and see only pictures. So on pictures is like always this side.
No. Okay, we cannot spend 2 hours, but the reason is because they love so much boomerang that they save at home. So, any Australian house is a boomerang. So, in an unconscious way, they just remember boomerang in this way. So this is my personal discovery. Of course, I don't know it's true. And if you ask an Australian guy, all the Australian people draw, it will just tell you they're crazy. But if you make the test, so if you really want to know if a person is from Australia, this is a technique. And these are very hard. I don't think you will resolve these quiz because it's very complicated. So fish around the world is a candy. Because we don't care if the fish go right or left. Who cares? No. But people from Japan and India, for example, they really love to draw the fish that go to this direction. Why?
This is how we learn to draw it in school.
Oh, you are from me? Are you from? Okay, so this is the answer. I have another answer that is wrong, but it is my hypothesis. So, because I was a big debate in Twitter, in Twitter always meaningful conversation, about the direction of fish. And a few people from India told me, well, I have a theory. The theory is, when we go to eat outside, no, a guy from Japan. So I don't know, I don't have any clue why it happened in India, but a guy from Japan told me that usually they don't cook at home because they have a very small house. So always they eating fish that is very smelly outside in a restaurant. And it's tradition in the Japanese cuisine to offer the fish with the head, and always they go from right to left. Always. It's a culinary tradition. It's like for luckiness, I don't know the reason, but so in a very unconscious way. But the nice part of this research that nobody knows that they draw the fish in this direction in Japan. They think that they draw the fish in a candy way, but it's not true. Exactly. They always eat alone. Exactly. This is a very smart consideration, but Japanese are always alone. Just. So, traffic light, of course, is very easy. Understand the cultural difference. The beer looks like more like a manga beer in area in Japan. Snowman is sometimes with 3, sometimes with 2 components. And so you can see some cultural affinity between the country. I don't know, Australian people, when they think about watermelon, they think it's ready to go. So Ukrainians like to save the watermelon for later, I don't know. But this is the overview of this project about fish. Now, I don't know, I have 4 minutes. in 4 minutes, I can show the last 100 slides. And no. I think I was very interesting follow different speech during the last few days, so I decided to bring back a very old project of mine about face. So many years ago, I was building this actor mirror where you show, okay, I don't have really friends that are actors, I need to use a picture, but if you put your face on the mirror, you will see the actor that is close to you. So I think soon I will put my face, I disappear, where I'm going. Oh, another one. This just to show that the system works. I was very proud at that time. I was very high-tech. So there are many things that are illegal here, like you cannot take all these pictures from an actor without ask, and you cannot use all this biometric data without ask. But it was one of my first projects in the field. Yeah, it never goes wrong. And during a meeting in IBM, I was screenshot the people in the, yeah. Obviously. So, but you know, some people are really identify the twins. So some person that was running close to my lab got shocked to discover that I were twins, because this collection of actors is very huge. Because I was really in the mood to collect face at that time. Then I cancel everything. I say to the camera, there is no more face in my computer. And sometimes, of course, there is some bias because you have a glass. But a nice feature that was really, I think, unpolarity was to push the system to identify other gender, other age. So it's possible to manipulate age and gender to find the close person to you. So essentially, everything is based to the face encoding. And this is the technology that we cannot use more. It's gone. So, and I proposed you other technology yesterday, using neural net trained to do the same things. But you cannot decode in this vector a face, not anymore, because this is a clear violation of privacy in the European community. But you can do in Brazil or in other countries. So, and this is the way usually comparison works. So you have this Euclidean distance between the vector in this multidimensional space. So it's very, very easy technology. In NumPy, there are so many functions that make this performance. The computer can calculate and compare millions of people in just a fraction of a second. So I decided to look in a different way movie. So essentially, I was thinking, what if I look at a movie in function to the interaction of the character? And I did this experiment. You have the counter there. So you need to know that this looks very easy, just a face detection, but it's not just face detection, because you need to be sure that you don't count a person 2 times. And always you need to be sure that you have the same ID during all the movie. So it's a little bit complicated. You know that it's complicated. Say yes. Go. So this is the full movie we can watch. Or we can look at the interactive tool. Essentially, these are all the sequence from the movie, and here's the interaction between character. Of course, this was just 5 minutes, this movie. So I think it's a beautiful way to watch a movie. Never again in a traditional way, just with a network approach. So Laszlo Barabasi is using my tool every night, close to the movie. Yeah, no, obviously not. It's not available, this tool, unfortunately. But really work well. You can see this timeline is based to the dominant color in each frame, and you can see, I think I have some, yeah. You can see here, wow, there is a sequence, and then there is a new sequence. So by the system is able to identify different camera movement and things like that. So essentially, this technology can be very useful for many exploration of I don't know, typical way to dress around the city. So this was many years ago when this was allowed, and honestly, this is still allowed because this is a recording from St. Petersburg, where there is no still a legislation that stop to extract biometric information from people. So all these information are something that we can easily extract. So essentially, counting how many people we want in the crowd, and our system is very stable. Identify other components, like in this case, car and people. Not just the body, but the face too. And this is just me walking on the street with my Google Glass. No, with just my camera this way. So everybody was looking at me in a very strange way, except in St. Petersburg, where everybody was feeling it was normal. I don't know. Of course, there are very clear resolution limits, so you really know who is this guy when he's go close to your camera. But when he's far away, you don't have enough pixels to understand too much. So I want to give you this overview to understand what was possible to do before. No more, it's gone. So collect all this information and the age of the people and the torso color. So black, yellow, white. You have this combination of information that you can cross. So identify ethnicity, everything in real time, of course. And shirt color type, you can say why you need to collect all this information. Because you can build a visual search. This is an engine to build visual search. Like you're looking for magenta top. So top is a frontal person, not from the back, it's from the front. And you use a magenta t-shirt. So you look a million of hours of video and give you the frame where there is a person with magenta hair. We find a lot of criminal in this way. This is a base technology the police use. And this torso and sunglass. So you have a sunglass, you're in front of the camera, and you can see this list is an interactive tool. It's a very long list. So now you know what policemen are still allowed to use, but scientists, normal people cannot use more. Essentially, the government take the copyright to have this technology for itself. Back to my movie, because this is really the important part. The geometric distance can be very meaningful to identify the. Let me know when I have to stop, because I can talk forever. So, yeah, let's wrap it up. So to wrap it up, there is a space connection, temporal connection between characters. So I use this technology to look at different movie and then obtain this a little sequence of this movie, and then obtain the graph. So that you cannot really understand this graph, but there was a lot of interaction in terms of time connection between these three people, and a lot of connection in timing, because this camera was really like zooming the face and then move to another face. So very strong correlation between these other people. This is 2001 Odyssey in the Space. In this case, I can show you the full movie. So this is the full movie. There are not so many characters, so it was very easy to plot. If you try to plot a war movie, unfortunately, there are so many faces that appear that you cannot do it. So I think I can stop here. Just I want to tell you that it's not just possible to explore what's going on in terms of correlation between faces that stay in the same frame or in the timing are close, but we can explore the camera movement. By looking all the frame, the sequence, we can recognize multiple camera movement. Essentially, we can extract a vector that is very representative of the style, the director, the way that people engage, the way that the main actor emerge and collaborate with other people, the villain. So there is an entire area to explore. I think can be very interesting to you, because there are very few papers in exploration of storytelling in movie. There are many, but not so good. So there is still time to improve. This was my last I close with this suggestion to maybe work in this direction, and of course with new type of technology that is based to neural net. Thank you.